In this video, we're going to factor some polynomials. So here, number 26, first thing I notice is that it's a binomial. Anytime it's a binomial, I look for difference of squares, sum of cubes, or difference of cubes. The fact that we have x to the fourth tells me it's not anything with cubes, so I have to double check if it's something with squared. Since it tells me to factor, I'm going to assume I can factor here. 25 and 36 are both perfect square numbers. X to the fourth is also a perfect square number. So you don't need to write it like this, but you need to be able to think of it at least. This is 5x squared being squared minus 6 squared. So my factoring is 5x squared plus 6 times 5x squared minus 6. And that's it. That's the whole thing. The 1 plus 1 minus makes sure the middle terms cancel each other out, because if I do last or outside times outside, so negative 30x squared, inside times inside is a positive 30x squared. They add up to 0. Okay. Number 27, first thing that I'm going to look for, since there's multiple variables, is there a specific variable that's in everything? In this case, b is in everything. And better than b squared is in everything. Why that's better is because now, when I factor that out, I'm going to end up with this. B squared times, I don't know why I wrote a 1 there, it should be an a squared, minus 8ab plus 16b squared. I'm using my exponent properties to subtract the exponents from those b bases. I now need to worry about factoring that remaining trinomial. In doing so, this b squared still needs to be out here. With a's and b's, it looks more confusing, but if I think of those a's and b's as like ones, sometimes that helps a little bit. Or the a was an x and the b was a 1, something like that, so it's a little bit more familiar. But I know that a times a is a squared. I know that 4b times 4b is 16b squared. But because I need that minus 8ab, I'm going to make these both minus. If I did the outside times outside, that's a times negative 4b. That's minus 4ab. Inside times inside is another minus 4ab. Together, that makes negative 8ab. The shortest way to write this answer would be like this. If you put the b squared after the a minus 4b, that a looks too much like a weird 9, so I'm going to change that. It would be fine, but generally we put the monomial first because it looks better. Okay, and then number 28 will be the last one for this video. I want to see if there's a common thing in every piece. There's a common thing in 2 or 3 pieces, but never in 4 pieces. So this is where I'm going to factor by grouping because there's 4 terms. So I'm going to treat this like a plus negative 4y squared. In this first binomial, they both have x squared. What's left is a y squared minus 3. That's my target to leave behind now. So I'm going to factor out a negative 4 to leave behind a y squared minus 3. When I say that's my target, that's a hint for what I might need to factor out. Looking at 4y squared plus 12, negative 4y squared plus 12, excuse me, maybe the numbers are nice enough that the 4 is obvious, but sometimes seeing this 3 says, okay, well, 12 divided by 3 is 4. I should factor out a 4, and that can kind of help speed up your thought process a little bit. But now both of these have a y squared minus 3, which is great. I now also have an x squared minus 4 being multiplied. But I'm not done, okay? The x squared minus 4 is a difference of squares. So x plus 2, x minus 2. It's the most basic one we could probably give you. 3 is not a perfect square, so we can just leave this as y squared minus 3. If you went crazy and used square roots and said y plus square root of 3, y minus square root of 3, I'm not going to get upset at you, but that doesn't really help our case, so we can stop just right there. Have a great day, everybody.